In this video, I'll go over the MergeSort algorithm, which is a recursive algorithm. Here we have the function MergeSort. It returns void, receives the parameters, the vector itself, and two indices. The indices basically from, which is the starting index of the list, and to, which is the end index of the list. In the algorithm, first you check to see whether the index from and to they are the same. Basically, you have check to see whether you have one element. If that's the case, you return a single element list. It's already sorted. Next, you find the middle index of this vector. To find the middle index, you add up the starting index from to the end index to and divide it by 2. That gives you the middle index. Having the middle index, I can now split the vector into two sublists, basically two almost equal sublists. And as pictorially as you can see, the original list now is divided into two sublists, and that is part of recursion. Remember, in recursion, you try to reduce the size of the problem. Same problem, but reduce the size of it. That's exactly what we are doing. The original problem is split into two sublists, smaller size, but now we'll try to sort the first list and sort the second sublist separately, and then merge the two sorted lists. And that's what's happening here. You call the merge sort on vector A, start from the starting index and go all the way to the mid. That's this sublist basically that you see right here, and after that call another recursive call to merge sort, send the list, the vector, start from mid index plus 1, that's this one, this index of number 9, and all the way to the end. Now once the two sublists are sorted, what you do, you start merging them. You call the merge function, and that merge function will be in charge of combining the two sorted sublists into one list. Now, as the code shows, the merge sort is recursively called on each of these sublists. That means that the same code is executed on each of these sublists. So what takes place is that you'll check to see whether this list is made up of a single element. If that's the case, you return. If not, you split it in half. Do the same thing for the second sublist, split in half. Next, we'll sort each of the four sublists that you see right here. We sort them and then we merge them. But in order to sort them, again, you have to make this recursive call, merge sort. So merge sort is executed on these vectors as well. So what happens, again, you check whether there's a single element in there. If not, you split in half, as you can see right here. So you have all these sublists. Now you're going to sort once again and merge these sublists. So you have basically reached the bottom of recursion. All these previous recursive calls, they are pending. They're not finished yet. They're waiting for basically the return value of other recursive calls. So once you reach this level, what happens? The vector consists of single element only. And basically you hit this condition if from is equal to 2, it comes out to be true, and then you return. So, and then the next step would be to merge them. So you will merge these two supposedly sorted sublists, each consisting of one element. And it's very easy. You just compare them, and 27 comes first, 38 goes second. Same thing with this pair. You merge them, you merge these two, and this was made up of single element, and that return, just 10 is returned basically. Right? So at this stage, you have reached the bottom of recursion, and all you're doing, you keep executing this merge. Now you have two sublists, each of two elements. You merge those two into this 4-element sublist. In this other case, you have two sublists, one 2-element elements, the other one element. You merge them. This is the sorted sublist that you get, and then finally you merge these two sublists. Keep in mind there, each of them is sorted now. You merge the two sorted sublists and you come up with the final answer. Now also one thing that you should keep in mind is that this vector, this list, is never split into pieces. It is intact. It stays intact as a continuous segment. Pictorially, we'll split them into pieces so that it is easy for you to see what is going on. But in reality, it is just these indices from to, that's basically guiding this algorithm to move things around.